Yo, what's up everyone, it's Algorithm Al. Listen, if you're watching this, you're probably in the tech game, grinding leak code and prepping for those FAANG interviews, am I right? We all know they don't mess around with those technical rounds. And one thing's for sure, you can't escape operating systems. So to help you absolutely crush those interviews, I've boiled down OS to the 5 most essential topics. The stuff these tech giants really grill you on. Whether you're just starting out with OS or need a quick refresher before D-Day, stick around because this video is basically your cheat sheet to acing those FAANG interviews. Alright, let's kick things off with the fundamentals. Processes and threads. Think of a process like an app running on your phone. You got Instagram, Spotify, maybe even some hardcore coding going on all at the same time. Each of those is a process, a separate, independent program doing its own thing. And just like your apps have their own data, each process gets its own memory space. Now within a process, you have threads. These are like the mini tasks that a process needs to get done. For example, your music app has a thread for playing the song, another for displaying the album art, and yet another for downloading the next track in the background. They all share the same memory space and resources within the app, making them super efficient. Interviewers love to throw this curveball. What's the difference between a process and a thread? Nail this basic concept and you're already ahead of the game, but it doesn't stop there. They'll also want to know about context switching, how the OS seamlessly jumps between processes to keep everything running smoothly. Picture a juggler keeping multiple balls in the air. That's your OS, my friends. And don't forget about process states. Ready, running, waiting, terminated. It's how the OS keeps everything organized and running without a hitch. Next up, we're diving into the world of memory management. Think of your computer's RAM like a giant warehouse and the OS is the super organized manager. It decides which programs get which shelves, how much space they get, and makes sure everything fits without crashing. One of the key concepts here is paging. It's like dividing that warehouse into equal-sized storage units. Each program gets a few units, and the OS keeps track of everything using a page table. It's like the warehouse manager's master spreadsheet. Then you have segmentation, which is a bit more flexible. Instead of fixed-size units, it divides memory based on logical chunks of data. Think of it like having different sections in the warehouse for different types of goods. But here's where the real magic happens. Virtual memory. It's like having a secret underground level in our warehouse. Chapter 3. Deadlocks, the ultimate traffic jam. Okay people, let's talk deadlocks. Imagine you're stuck in traffic, but like, really stuck. Nobody's moving because everyone is waiting for the car in front of them to move first. That's a deadlock in a nutshell, but instead of cars, we're talking about processes fighting over resources. To really understand deadlocks, you gotta know the 4 Coffman conditions. Mutual exclusion, hold and wait, no preemption, and circular wait. These are like the 4 horsemen of the deadlock apocalypse. But fear not, my friends, because there are ways to deal with these deadlock demons. We've got techniques like resource allocation graphs, deadlock detection algorithms, and the banker's algorithm. These tools help ensure no one gets stuck. Chapter 4. CPU scheduling, who gets to go first? Now let's talk about CPU scheduling because even in the digital world, time is precious. When multiple processes are lined up, all wanting a piece of that sweet, sweet CPU time, the OS steps in as the ultimate timekeeper, deciding who gets to go first. It's like air traffic control for your computer. There are a bunch of scheduling algorithms out there, each with its own pros and cons. You've got FCFS, the first come, first served approach, which is about as fair as it gets. Then there's SJF, or shortest job first, which prioritizes quick tasks to keep things moving. Round robin is all about sharing, giving each process a fixed time slice to work with. Priority scheduling lets higher priority processes jump the queue. And finally, multi-level queue scheduling is like having different lines for different types of processes. Chapter 5. Synchronization, avoiding data disasters. In the world of multi-threading, where multiple threads are accessing shared data at lightning speed, things can get messy. It's like having multiple chefs trying to use the same ingredients at the same time. Chaos is inevitable. This is where synchronization tools like Mutexes, Semaphores, and monitors come in. They act as traffic cops, ensuring that only one thread can access critical sections of code at a time. Think of it like a lock on a shared resource. Only one thread can hold the key at any given time, preventing data corruption and race conditions. Speaking of race conditions, be prepared to face some classic synchronization problems in your interviews. The producer-consumer problem, the dining-philosopher's problem, and the reader-writer problem are all fair game. These scenarios test your ability to think critically about how multiple threads interact and how to prevent those interactions from turning into a disaster. Outrow level up your OS game. So there you have it, guys, the 5 OS essentials that will have you walking into those FAANG interviews with confidence. We covered processes and threads, memory management, those pesky deadlocks, CPU scheduling, and the art of synchronization. Master these concepts, and you'll be well equipped to handle whatever those interviewers throw at you. Until next time, keep those algorithms sharp, and I'll catch you in the next one. Peace.